I'm going to go through the problem 5.010 from the problems that are assigned to you in your homework problem for tonight. This is a problem of superposition. Some of you have had questions about superposition, how we can apply it. First thing I have to say is that the superposition, meaning that you solve it for each sources and then you add whatever result you want to look at. In this case, we want to look at the I0, so we find the I0 for the case that we only have one of them. For example, if we take this one out and we have this current source, and how much would be the I0? The second time we take this one out and look at the current that is caused by this 12 volt source, and then we add those two currents together. So the first step in finding that is if I short this side of it, and then if I short this side of it and I only have this source as my source for providing the current. So my circuit is going to be something like this. So I have shorted this, so I have a short circuit over here. Then this 6K and this 6K are going to become parallel. When they become parallel, you can find the equivalent resistance. So 6 parallel to 6 is going to be 6 times 6 over 6 plus 6. So this is going to be 3 kilo ohm. So I can actually replace these two with a 3 kilo ohm coming that way, coming down. And if I do that, it's a 3K. It is a 3K coming to a 6K. Then it is this current source of a 6 milliampere. Then this is connected to this 6K, and I'm looking at this I0 prime. In order to find the I0 prime, I have to divide the current between these two. The current division that we went through in parallel resistors is that, so okay, so these two are going to give me a 9K. So basically my circuit is like this: 6K, 9K, and I'm looking at the I0 prime. So this current source is 6 milliampere. So the 6 milliampere, the I0 prime is equal to 9 over 6 plus 9 times this 6 milliampere. So this is equal to 6 plus 9 is 15, 9 over 15 times 6. So this is going to be 3.6 milliampere. But you need to know that at 3.6, this current is going this way basically, and this way. So this is how it is divided. So this is negative 3.6. Okay, so the next step is to short, okay, so we already have shorted that. So we are going to take this one out. Taking the current source out is having the 6 milliampere out of that, so it is an open circuit. So if I make an open circuit of that, so this is my source, this is an open circuit, then I have this one in series with that one, and then it is in parallel with this one. So let's see what the solution, how we can solve it. In order to solve it, so I have opened that, so 6 and 6 is going to add up. So I have a 6 and I have a 6 over here, 6K and a 6K over here. And then I want to change my 12 volt source to a current source as I was able to do it before. So I'm going to have 6K over here, and I'm looking at this I0 double prime. So I have a 6K over here, and the 12 volts plus and minus 12 volts. So this 12 volts I want to change it with a current source So the current source is going to flow, so make sure that you go from negative to positive, is going to flow this way, and it is this 6K is going to be in parallel with that, and then I have a 6K over here, so it is going to be in parallel with that. So I have a 6K over here, I have a 6K over here, that is going to be a 6K over here and a 6K over here. It is how I can connect it, 6K and a 6K, and this is my I0 double prime. But we gotta make sure that you put the current over here correctly. So if you have a 12 volts and a 6K, your current is going to be 12 over 6, it is 2 milliampere. So, and then these two are going to be parallel, so I can redraw it this way, saying that this is my current source, this is a 3K, so 6 parallel to 6 is 3K. So we had that. This is basically 6 times 6 over 6 plus 6. So I have a 3K over here, and I have a 6 and a 6 over here, 6K and a 6K over here. So my current, and this 2 milliampere. So my current is going to be, so a current division again. So my current is going to be I double prime, I0 double prime is actually the 3, we use this resistor, over 3 plus 6 plus 6 times 2 milliampere. So this is going to give me, the answer is going to be 3 over 6, and 6 is 12, and 6 is 15, 12 and 3, sorry, is going to be 15, 3 over 15 times 2 milliampere. This is going to be 0.4 milliampere. So one of the currents that I had was the I0, is going to be I0 prime plus I0 double prime. This is minus 3.2, that's what we had from before, plus 0.4 milliampere. So this is going to be, oh, this is 3.6, sorry. And then I'm going to have minus 3.2 milliampere is my I0.